Hi my dear students, I'm Daphne Cole. Welcome to my STPM chemistry discussions. Today we will discuss about optical isomerism. What is optical isomerism? Now look at our both hands. Both hands are mirror image of each other. Even they appear to be the same, but if I try to put one hand to another like this, both of my hands cannot superimpose each other because of their Now, let's look at the first part. What is the definitions of optical isomerism?
My dear students, before we go to the part of optical isomerism, let's recall that isomers are different compounds with same molecular formula. In some cases, molecules may have the same chemical formula but different 2D or 3D arrangement of their atoms. The two major classes of isomers are structural isomerism and stereoisomerism. These are the different categories of the structural isomerism, while stereoisomerism can be categorized into following type. The first one, geometrical isomerism and optical isomerism. In this video, we focus on optical isomerism and use alkane compound as example to explain the isomers. I will discuss geometry isomerism in my next video. You may push the subscribe button to subscribe my YouTube channel so that you won't miss out my lesson. Of course, optical isomerism is a very common scientific term that appears in STPM examinations paper. So you need to know the characteristic of optical isomers. Here, I show you some passive questions that require the candidate to understand well on optical isomerism. It's important to mention that the stereoisomerism is very important concept. So you should know how to draw optical isomers, including identify the chiral carbon in the compounds. Now, let's see what is the definitions of optical isomerism and what are the conditions for optical isomerism. Optical isomerism, also known as enantiomerism, is a concept in chemistry that refers to a specific type of stereoisomerism. It arises when two or more molecules are non-superimposable mirror image of each other. This is similar to our hands. In other words, optical isomers are molecules that have the same molecular formula and connectivity of atom but differ in their spatial arrangement. The first condition is the presence of at least one chiral carbon in a molecule. This is because chiral center can result in the formations of optical isomers with non-superimposable mirror image called enantiomers. Always bear in mind that chiral molecules are non-superimposable on their mirror image. If the object and its mirror image are the same, they are superimposable. If the object and its mirror image are not the same, then they are non-superimposable image. Therefore, any object that is non-superimposable to its mirror image is said to be chiral. Now you must be wondering what we mean by non-superimposable. Just like our right and left hand, when the mirror image of the object is placed over the original object and they do not overlap.
Chiral carbon, also known as asymmetry carbons, refer to the carbon atom that is bonded to four different groups. An asterisk is used to identify this chiral carbon. My dear students, just a reminder, the easier way to determine if the molecule has optical isomers is to draw their display formula. The two different optical isomers, also known as enantiomers. That means enantiomers are chiral molecules that are mirror image of each other. Now, let's look at example 1. Which of the following molecules are optically active? Draw the enantiomers. If the carbon atom with the tetrahedral arrangement is attached to 4 different groups, then it is a chiral carbon. From the structural formula, the carbon label number 3 is attached to 4 different groups, therefore the carbon is a chiral carbon. Is carbon atom C4 a chiral carbon? There are only 3 different groups attached to the carbon C4. Therefore, carbon atom C4 is not a chiral center. After we determine the chiral carbon in the molecule, then we draw a pair of enantiomer. At first, draw the molecule in the shape of tetrahedral arrangement. For these questions, we need to circle all the chiral carbon, but how to identify chiral carbon in aromatic structure? Let's see an example. How many chiral carbon are in the following molecule? In the ring structure, if we want to determine the chiral carbon, we need to determine which carbon atom is attached to 4 different groups. At first, we need to ignore all atoms that cannot be chiral carbon. These include carbon C3, C4, C5, and C6. These carbons are not chiral carbon. This is because each of these carbons attached to 2 hydrogen atoms. Next, we need to check on carbon C1 and C2. Now, let's check the number of different groups that attach to C1 and C2. If you refer to the diagram here, there are 4 different groups attached to the carbon C1. Therefore, C1 is chiral carbon. Now, let's come back to the example 2. From the structure, we can ignore each of these carbon attached to 2 hydrogen atoms. Therefore, they are not chiral carbon. Next, let's look at carbon C5. How about carbon C1 and C2?